Hello dear students, welcome back to my lesson. So on today's lesson we're going to explain angular acceleration and the variation of the angular speed. In a previous lesson we discussed about the angular speed for rotational motion on an object, and also we studied the angular displacement for rotational motion. So for today's lesson, let's start with the angular acceleration. Its symbol is alpha. It came from the Greek letter. What is the alpha? Is the angular acceleration in rotational motion. But in translational motion, as you learned in grade 11, we had an acceleration, not angular acceleration. Its symbol was A. Okay, but this is alpha. Be careful. What is the definition of angular acceleration? The time rate. When we see the time rate, it means that the denominator of the fraction should be time. Okay, so the time rate of what? Change of angular speed. Change of what? Change of angular speed. So it means that the angular acceleration will occur in the case of changing angular speed. In the case where angular speed is constant or stay unchanged, there is no angular acceleration will occur. Okay, so the time rate of the change of the angular speed and express it in rad per second squared. This is alpha, okay, is equal to what? Time rate of what? Delta omega. What do we mean by delta omega? It means that the variation of the angular speed or the change of angular speed. So which is equal to omega final minus omega initial. And express it in rad per second because omega measured in rad, and the rad per second, angular speed measured in rad per second divided by second becomes second squared. So that is why angular acceleration is measured in second squared. A is angular acceleration, delta omega is change in angular speed, the time interval measured in second, omega initial angular speed, omega final angular speed. Okay. We have some important notes about the angular acceleration for rotational motion, as you can see in the upside down bicycle. If the object starts rotating from rest, which means that omega initial is equal to 0. When does omega initial is equal to 0? If the question says the object starts rotating from rest. Okay, this is the first one. The second note, if an object stops rotating after a while, it is omega final becomes 0. If you see the question, the object stopped rotating after 5 seconds, for example, so you have to know the omega final is equal to 0. If you see the words of the stop, which means that omega final is 0. Okay? Or the object comes to stop rotating, also omega final is equal to 0. The third note is very important, be careful. When an object accelerates, when an object accelerates from rotation. What do you mean by accelerates from rotation? It means that speeding up. In the case of the speeding up, omega final is bigger than omega initial. When omega final is bigger than omega initial, then alpha becomes positive. Why? According to the equation of angular acceleration is equal to omega final minus initial. Bigger minus, the bigger value minus the smaller value, the result becomes positive. Okay? So, in the case of the decelerates from rotation or slowing down, omega initial bigger than omega final. It means that the object is rotating until it becomes slowing down until it reaches 0, until it stops. So in that case, omega initial is bigger than omega final, and the value of alpha becomes negative. So when does angular acceleration has positive sign? In the case of speeding up. In the case of speeding up, omega final is bigger than omega initial. When does alpha or angular acceleration has negative sign? In the case of slow down or slow rotating. In that case, omega initial is bigger than the omega final. So when an object rotates with constant angular speed, rotate with what? Constant angular speed. Please pay attention. This point is very important. At constant angular speed, omega initial is equal to omega final. So when omega initial is equal to the omega final, delta omega is equal to what? 0. 0 divided by time is equal to 0. So alpha becomes 0 in the case of constant angular speed. As in the previous lesson, we studied and we solved some constant angular speed for some quantities, such as, for example, the rotating the second hand, minute hand, and hour hand of the clock is constant, and they have 0 angular acceleration. And also, the angular acceleration of the rotating Earth around itself is 0. Why? Because the angular speed of the rotating Earth around itself is 0. The orbiting Earth around the Sun has 0 angular acceleration. Why? Because the orbiting Earth around the Sun has constant angular speed. So, angular acceleration, as I told you, is 0 for the clock's hand and orbiting Earth around the Sun or all other planets. Why? Because delta omega is 0 and alpha is 0. And a rotation object always has angular displacement for every rotation. For every rotating object, we have angular displacement. Okay? So without angular displacement, no rotation will occur. And angular speed is also necessary for every rotating object. But it doesn't necessarily have angular acceleration. It means that, is it necessary for every rotating object has angular acceleration? No. Because in the case when the object rotating at constant angular speed has no angular acceleration. Okay? So what is necessary for rotational motion to be occur? The angular displacement and the angular speed. So angular speed must change for angular acceleration to be formed. So we have some ministerial questions here. I'm going to show you. Okay? Question 1. The magnitude of the average angular acceleration. Average what? Angular acceleration alpha of the second hand of clock is equal to what? Is equal to 0. Why? Because alpha is equal to change in angular speed divided by t. Change angular speed for second hand of the clock is equal to 0. 0 rad per second square. Okay, the correct answer is 0. Why? Because second hand has constant angular speed. Question 2. If an object has tangential acceleration of positive 10 meter per second square, tangential acceleration positive 10 meter per second square. In that case, when tangential acceleration is positive, alpha also has positive sign. When does alpha has positive sign? In the case when omega final bigger than omega initial. So, in that case, the object's angular speed increase or decrease. So, the angular speed will do which of the following? When does omega final is equal to omega initial? When the object has speeding up. Okay, speed up. So, in the case of positive sign, it should be increase. If an object, so this question has been brought in ministry in Wazari exam, be careful. This is the third question. If an object has tangential acceleration negative 10 meter per second square, in that case, because tangential acceleration is negative, so the angular acceleration is also should be negative. When does angular acceleration becomes negative? In the case when omega initial bigger than omega final. When does omega initial bigger than omega final? In the case of slow down. So the speed should be decreases. The correct answer is decreases. Okay? Another question. If an object has zero tangential acceleration, AT 0. When does tangential acceleration has 0? When angular acceleration has 0. Okay? So when does angular acceleration becomes 0? In the case when the object's initial angular speed is equal to final angular speed at constant speed. Okay? So in that case, the angular speed will do which of the following? Stay the same. Okay? If the angular speed stay the same, tangential acceleration and angular acceleration becomes 0. Okay? Another question, the last question. A top that is spinning at 15 rev per second, spins for 55 seconds before coming to stop. So what is this? This is omega initial. Omega initial was given 50 rev per second. So we have to convert to rad. as I told you, for every solving questions, the angular displacement must be in rad, not rev, not degree. In the case when the angular speed is given rev per second or rev per minute, we have to convert to rad per second. We have to multiply by 2 pi. Omega initial is equal to 30 pi rad per second. Speeds for 55 seconds, delta t. The time interval was given also, 55 seconds. Before coming to stall, as I told you, if you see the stall in the question, this stall indicates that the final angular speed is 0. Okay? Omega final is 0. How did you know omega final is 0? Because the question says before coming to stall. Okay? Rad per second. What is the average angular acceleration of the top wheel? It is slowing. Okay? So in that case, the angular speed is slowing from 30 pi rad per second to 0 rad per second. So alpha, it should be negative. Without solving the question, you have to know the sign of the angular acceleration is negative. And at first, you have to write down the equation of angular acceleration, which is equal to omega final minus omega initial divided by t, 0 minus 30 pi divided by 5. Alpha is equal to 6 pi rad in negative per second squared. Okay? The correct answer is we have to multiply 0 minus omega initial was given 30 divided by pi is equal to 1.7 in negative rad per second. Okay? The sample problem sorry, the time was 55, not 5. Sorry, I mistaken. Okay? The time was given 55 seconds, which is angular acceleration. Sorry, I do apologize. Omega final minus omega initial divided by t. Omega final was given 0 minus 30 pi divided by 55, not 5. Okay, I wrote 5, I'm mistaken, sorry. So the alpha is equal to negative 1.7 rad per second squared. Okay? Okay. Sample problem 1c. A car's tire rotates at initial angular speed. What is this? This is initial angular speed. Was given 21.5 rad per second. So the driver acceleration and after 3.5, this is time. The tire's angular speed increases from 21.5 to 28 rad. So in that case, because omega final bigger than omega initial, alpha becomes positive. In the case of speeding up, angular acceleration has positive sign. What is the tire's average angular acceleration during 3.5 times interval? So all the given values are shown here, so you can replace into the equation to find the alpha is positive. Okay? So this question is homework. I hope you solve by yourself. Okay? And practice 1c, as we can see. Practice 1c question 1. It's too easy, just replace, okay? Fill in the unknown quantities in the following table. In this table, we have angular acceleration, change of angular speed instead of omega initial and omega final. The change in angular speed is given directly, okay? So, you are not required to know the initial and final values. And the time intervals also given in the table. For the first branch A, what is unknown? Angular acceleration. Just replace delta omega divided by t. So in the branch B, what is unknown? Delta omega. Delta omega is equal to what? If you rearrange the equation, is equal to alpha times t. And branch C, be careful. The change in angular speed was given in rev per second. Okay? So if the angular speed is negative, also the angular acceleration is negative. Because the angular acceleration has the same sign of angular speed. Okay? Branch A angular speed was given in positive. The angular acceleration also was positive. Branch C angular speed, change in angular speed was given in negative. Angular acceleration also should be negative. Okay? Multiply by 2 pi. Why? Because we have to convert rev to what? To rod. Multiply by what? By 2 pi. Okay? So, angular speed and acceleration of a solid body rotating about an axis. For example, in a Ferris wheel, when it's rotating, the Ferris wheel has rotational motion. Okay? But all the points on the Ferris wheel, like the chairs and the balls, undergoes a circular motion. Okay? So, every point on the rotating object, they have the same angular speed. Every point on the rotating object, they have the same angular speed. But it is linear, quantities are different. Different with the variation of the distance from the axis of rotation. Okay? So, if a point on the rim of bicycle or rigid body will have an angular speed greater than the point B, in the case when omega A is bigger than omega B, what's happened near the center? The shape of the wheel will be changed. Okay? So, when we say for the rigid body, all the points, they have the same angular speed, okay? But for non-rigid body, in the case, for example, when you throw up a pizza, for pizza makers, they make a pizza, when they throw it into the air, what happened to the shape of the pizza? It becomes bigger. So it means that this change of the shape of the pizza, it means that this object is not rigid. For non-rigid object, the value of the angular speed for each point is not equal. Okay? So it means that to prevent the size of the object, such as the wheel of the car, the wheel of bicycle, merry-go, Ferris wheel, because they are rigid body, their shapes do not change during the rotation. That is why all points, they have the same angular speed. Okay? So for rotating object to remain rigidity, stay unchanged, like bicycle's wheel, the car's wheel, Ferris wheel, merry-go-round, such as a wheel, bicycle or Ferris wheel, every portion, every point of the object must have what? Same angular speed. For rigid body, for example, this is rigid body and this is the axis of rotation, okay? If you have 2 points, okay? Point A, point B, and the object is rotating. For rigid body, assume that this object is what? Rigid body. Okay? For rigid body, omega B at point B is equal to omega A. They have the same angular speed. There is no difference of the angular speed. And also, they have the same angular acceleration. Their angular acceleration is the same if it has. And also, the angular displacement is the same. Okay? Theta B is equal to theta A. So, which means that for rigid body, during the rotation, the quantities of the rotational motion doesn't change. Okay? But it is linear quantities changes. Why? Because the distance from the axis of rotation. For example, which one has more tangential speed? Absolutely, A has more tangential speed. We will study in detail in the next lesson, inshallah. So VB is less than VA. If the object has acceleration, AB less than, AB less than AA, okay? So the acceleration of A is less than the acceleration if it has, okay? So for the distance from the axis of rotation, which one is bigger, RB or RA? Absolutely, RB less than RA. Okay, so we can conclude that the object that far away from the axis of rotation has more tangential speed, has more acceleration if it has, and has more radius or distance from its axis of rotation. Okay, look, as you can see, RA is not equal to RB, VA is not equal to VB. Okay, so but it is angular quantities are equal. When a wheel rotates about a fixed axis, when a wheel, what is wheel? Wheel is rigid body or non-rigid body? Wheel is a rigid body. Okay, about a fixed axis. Do all points on the wheel have the same angular speed? Yes. Yes, they have the same angular speed. Why? Because the wheel is rigid body. In the case when they have not the same angular speed, otherwise the wheel would change its shape. This is question 3 from chapter review. Very good question. Be careful. Okay? So it has been brought in Wizari exam many times. Question 8. When a wheel rotates, this question is similar to this one, but there is with a little difference. Okay? So now I'm going to tell you what is the difference between the question 3 and question 8. In question 8 says, when a wheel rotates about a fixed axis. Wheel. What is wheel? Rigid body. Do all points on the wheel have the same tangential speed? Absolutely no. Why? Because the points near the axis of rotation has less tangential speed than the points farther from the axis of rotation. Okay, no. The answer is no. They have the same angular speed, not angular displacement. Not angular speed, okay? Not tangential speed, sorry. They have the same angular speed, not tangential speed. Okay? If 2 delta theta or 2 delta t are given in the question, you can use this equation because for every point on the rigid body, like omega b is equal to omega a for rigid body. What is the equation of omega? Theta b divided by t is equal to omega, is equal to theta a divided by t. Okay, and also you can write down v1 over r1 is equal to v2 over r2. So this is the value of the linear quantities, and for the angular quantities, as you can see in this table, for the linear translational delta x, it changes to delta theta. So in linear translational motion we have v initial, but here we have omega initial. Instead of v final, we have omega final, and instead of a, we have alpha. Okay, therefore kinematic equation, as we studied in previous lesson, we have 4 kinematic equations. Okay, this is for rotational motion, and this is for translational motion. For rotational motion, in that case, these 4 equations can be used at constant angular acceleration. When angular acceleration is what? Is constant. So when this, you have to use the 4 kinematic equation for rotational motion when angular acceleration is constant in the question. It means that for uniform angular acceleration, these 4 equations can be used. So these 4 equations that you studied in grade 11 when acceleration is constant. Okay? So the quantity of omega in the above equation represent the instantaneous angular speed, not average. Be careful, because sometimes it will be complicated for the students, so it will be confused for the students because sometimes the students, they mix these 2 equations together. So this equation can be used to find the average angular speed. For what? Average angular speed. Okay, so what is the difference between the average angular speed and the angular speed in this equation? In these equations, the angular speed is represented for the instantaneous angular speed at constant angular acceleration. But in that case, it's not necessary that angular acceleration be constant. Okay, this changes. If an object rotates from rest, as I mentioned before, omega initial, v initial becomes 0. If a rotation object comes to rest, omega final and v final becomes 0. In the case of speeding up, alpha positive and omega final bigger than omega initial, and a is also becomes positive. Well, the negative is the same when angular speed remains constant, alpha is 0 and omega initial 0. Sample problem. The wheel on an upside down bicycle moves through 11 rad in 2 seconds. So what is this? 11 rad in 2 seconds. It means that delta theta was given 11 rad. T also was given 2 seconds. What is the wheel's angular acceleration if it is initial angular speed is 2 rad per second? Initial angular speed is given 2 rad per second. Okay? What is the angular acceleration? Angular acceleration is unknown. How can you determine the angular acceleration? Omega final minus omega initial divided by t. Replace. Final is not given, so in that case, we cannot use this equation, sorry. Okay? Can we use this one? No. Why? Because in this question, do we have omega final? No, we don't have omega final. Okay? And also alpha is unknown. That's why we cannot use this equation. Okay? So, the second equation is delta theta is equal to omega delta t plus 1 over 2 at squared. Can I use this equation? Yes, this equation can be used. And also, if you have a bad time in this case to using these four equations, in the case when the angular acceleration is not, when the omega final is not given, you have to use this one. Okay, when does this equation can be used? When omega final is not given and not required to find it. Okay, so we can replace it. 11 omega initial was given, 2 time also was given, plus 1 over 2. A is unknown. Sorry, this is not A, this is alpha. Alpha is unknown, time is t squared is equal to 4. Okay? So 11 is equal to 4 plus, this is cancelled, 2 alpha is remaining. You have to take this 4 to the other side, becomes negative. 2 alpha is equal to 11 minus 4. 2 alpha is equal to 7. Alpha is equal to 3.5 rad per second squared. Is equal to 3.5 rad per second squared. This is sample problem 1D. Okay? Practice 1D. Look at this question. A remote controlled car's wheel accelerates 22.4 rad per second. What is this? This is alpha. How did you know? By the unit. You can recognize all the physical quantity by the units. The units is rad per second squared, which is indicated for the angular acceleration. If the wheel begins with an angular speed of 10.8 rad per second, begin is that omega initial is 10.8 rad per second. What is the wheel's angular speed after exactly 3 full turns? After what? After exactly 3 full turns. So be careful, this is very important. Okay? What do you mean by after exactly 3 full turns? It means that how many turns do we have? 3 turns. Each turn indicates one complete cycle, which means that we have 3 revolutions. Theta was given in revolution. 3 rev. You have to compare to rad. Okay? 2 pi divided by 1 times 3. Or multiply by 2 pi. Theta is equal to what? 6 pi rad. Okay? So in this question, because the time is not given in this question, if the time is not given, as I told you, if you have a bad time to using or to select which equation can be used in the question, in the first case, as I told you in the previous question, this question, when does this equation can be used? Okay? Or when does this equation can be used? When delta theta is not given or not required to find. The second one, when time is not given or not required. The third equation, when omega final is not given and not required to find it. Okay, the last equation can be used when angular acceleration is not given and not required to find. Okay, if you have a bad time to select the equation, you can think about this way. Okay, so in this question, because we don't have time and the time is not given, that is why we have to use this equation. But be careful, you have to change or convert the units from rev to rad. Okay? So, how long does it take in the item 1 to make the 3 turns? Delta t, you can find delta t omega phi minus initial, replace is equal to 0.902 seconds. So that's all for today. Inshallah, in the next lesson, we will continue to solve all questions which is related with the angular acceleration. Thanks for listening. Hope you get benefits.